Alan Ding from the University of California, San Francisco, and the San Francisco VA.
And I'm Wellington Su from the Northwestern University Feinberg School of Medicine. And today, Dr. Dang and I will be talking about the exciting applications of 3D printing in spine surgery applications. Why don't we start by talking about the types of 3D printing and where you're seeing it affecting it?
Yeah, absolutely. So I think 3D printing is kind of a big catch-all buzzword. And the way you want to think about it is that it's additive manufacturing as opposed to traditional manufacturing. So if you think about the way most things used to be made, you would have a block of wood or a block of aluminum and it'd be milled down and you throw away all the stuff you don't want. Additive manufacturing is where you start with the stuff you want and you build it up, almost like Lego blocks. And it allows for kind of unique different applications that you wouldn't normally be able to get. Things like rapid prototyping, where you can custom do implants. And I think really there's been a lot of growth in the last year in terms of the way people use it academically, from a research standpoint, and even in clinical practice.
I agree with you in terms of the breadth of applications that 3D printing has. I think in particular there are two different types of categories where additive manufacturing can really help patients in general. The first is the construction of structural cages. Being at this meeting, seeing different types of devices being launched over the course of the year, we're seeing the effects of 3D printing of metal. Usually this is a direct laser sintering process where you can build a cage from the ground up, and as a result, it's much better than a conventional method where you are limited in terms of where you can put your chambers, where you can put your struts, and this increases the engineer's ability to construct a cage that a surgeon can use. I think another very important area where 3D printing can help is in biologics for fusion. There are different types of 3D printing now that we use that can preserve growth factor activity, that can help increase the traditional biomechanical properties of something like a ceramic where we can make it elastic, and we can actually hopefully one day construct a scaffold that will not require any exogenous growth factors in order to achieve a fusion. Without this technology, that type of strategy would be very difficult, but with these biomechanical advances, we're seeing a lot of interest in developing a strategy that can help all patients.
Yeah, and I think that's very interesting. When you look at last year compared to this year, most of the time when we've gone to like the expo floors, what you see are the companies that make these 3D printers advertising the different things that they can make. But this year we're starting to see there are actual clinical tools that, actual implants that you can buy from the mainstream manufacturers that, like you say, can do new things. I think the data will need to be developed to see how much better these are. But with the laser sintering, they're creating these cages with a lot more porosity, which may help with blood flow. And the concept with laser sintering for the audience is that you have powdered metal and you use a laser to kind of microscopically melt and fuse these things together to make it work. For the biologics, it's always been a challenge though, right? Because of the heat, and I know that you're doing some of the research to do these at room temperature. Can you tell the audience a little bit about that?
Yeah, it's a great point. So you make a great point in that the advances of 3D printers have not only come from the hardware side, but also from the software side. So even though these printers have more capabilities in terms of what they can construct, if there is not the right software to help direct that sort of technology, then there really is a wasted technology. So the case you bring up is that much of the conventional methods of constructing a 3D printed scaffold with a ceramic involves very high temperatures. And when that happens, the material, if you use hydroxyapatite, for example, becomes very brittle in your hands. And for surgeons, when we're using these type of products in spine fusion, regardless of the anatomic area, they are not very easily confined in a certain area. But with these novel techniques, with techniques that I have studied with my collaborators at Northwestern, we are now able to print materials at ambient room temperatures, and this allows the material to be much more flexible, much more versatile. And this, in addition to the preservation of growth factors, can lead to a very effective scaffold.
Yeah, and I think as I get the sense of how the market is changing, I think that the the patient-specific 3D printed thing is probably going a little bit away, because now that it's just a new tool where you don't really have to know how your car was made, it was just made. And I think the same thing is probably going to be true with a lot of these new implants that are just different or have new features, and probably the same with biologics, that they'll be able to pick up the thing off the shelf like any other biologic, but it'll have really nice handling characteristics that you wouldn't get because you can't cut and make these little pores in a way that you can with this 3D printing technology.
What do you think about the possibility of using 3D printing as a tool for training for some of our young surgeons who are in the crowd?
Yeah, that's actually probably where we use it the most at UCSF, so not actual patient care. But there's a big thing where you can use sawbones or plastic models, and they're never really diseased, and they're always really the standard American male, probably in size. And one of the things that we can do is we have a CAT scan, is we can contour out the bones and then print it out of plastic. And this gives the trainee a chance to play around and see it. And I think it's really nice because they can more accurately get a sense of, when we talk about these facets being very narrow and close to the midline versus facets being very wide, it helps them kind of understand the differences from patient to patient, and when we're doing the dissection, to avoid kind of any injury to critical structures. So I think that's where it is, and even outside of spine that we see it in terms of fracture care, and I think those are where it can be readily done now because the cost of it is so low. Buy a machine for maybe $1,000, and each print is about $3 to $4 only.
It's a great point. I think there are many thought leaders who feel that printing a spine, an entire spine of a patient before he or she undergoes surgery can improve preoperative planning, can improve the safety of instrumentation, and can even improve the efficiency in the OR. So I think it's fascinating that we can use these models not only as training tools, but also as care tools to improve the delivery of spine surgery.
Yeah, and it's been interesting that a lot of patients, we talk to them about this is what we're going to be doing. They love taking home that model at the end and say, this is my spine, and not just some random person's plastic model. Yeah. So that there's some good patient satisfaction when you use it as well.
Great. So in summary, both Dr. Dang and I are very excited about the prospects of the use of 3D printing in many different areas when it comes to spine surgery. And as our technology improves, the efficiency will improve, and I think we're going to see more and more, even more different applications than we are already talking about because of the availability of the technology.